All right, we're looking at the guided notes for chapter 3.3, and I put a couple of examples at the beginning of this for things that I know everybody here has already been able to do. In fact, I just got done grading all the exams, and I noticed that everybody in general is able to do these problems. Now, making sure we show our work, I want to do the first two problems. So, the first problem. Oh, where'd you go? I don't need you. Where'd you go here? Where's my pen? Oh, there it is. Okay. So the first problem, 3x equals 9, we divide both sides by 3. And this is how we show that work. We divide by 3. The 3's cancel. I'm left with x equals, and 9 divided by 3. I know 3 goes into 9 3 times, so x equals 3. Not too terrible. And what about this one here? We divide both sides by negative 2. And divide both sides by negative 2. And now we get y equals, and 18 divided by negative 2 is negative 9. And that would be my answer here. So, again, things we're relatively comfortable with, and things that that everybody in this class has been able to show me they can do. All right, so taking a look at the notes, it says we can treat inequalities the same as we do equalities. So the problems that we've been solving, these equalities, except when we multiply or divide both sides by a negative. By a negative. When that happens, we must flip the sign. That's a G. To ensure accuracy. Okay, so what does this mean? What am I saying by all this? Well, let's just take a look at 4 and 7, right? I think we all know where 4 and 7 lie on the number line, and I think we all could put together that 4 is less than 7. Right, so 4 is less than 7, and again, Pac-Man eats the bigger. Here's Pac-Man. He's chomping on the 7 because 7 is much bigger than 4. Well, okay, let's multiply 4 by negative 1. Yeah, that's going to give us negative 4, right? And if we multiply 7 by negative 1, we end up with negative 7. Now, which one is bigger? Is negative 4 bigger than negative 7, or is negative 7 bigger than negative 4? Well, negative 4 on that number line is going to be bigger than negative 7. So what happened? When I multiplied both sides of this inequality by negative 1, my sign must flip. Okay, so anytime we multiply or divide an inequality by a negative number, then the sign flips. That's the big difference. Otherwise, we're going to treat these inequalities just the same as we would an equality. Except, again, when we show our answers must be on a number line. Okay, so 3x is greater than 9. Let's divide both sides by 3. And it's a positive 3, so I'm just going to have x is greater than 3. And that I could do on a number line. Let me get my fancy number line out here. Fancy number line. Showing my arrows that tell me it goes on forever. Here we have a 0. Here I have negative 3. And here I have 3. And I want all the x values that are bigger than 3. And this is going to be an open circle. And I shade to the right. It's open because it's strictly greater than. Alright, so for problem number 2, negative 2y is less than or equal to 18. Well, I got to divide both sides here. Oh, whoa. Whoa. And divide both sides here by negative 2. Divide by negative 2. Divide by negative 2. It cancels that out, and I'm left with y. Now, I divided by a negative, so this sign must change here. And 18 divided by negative 2 is negative 9. So now y is greater than or equal to negative 9. Now let's show that on a number line here. I get my number line out. I got a big number line this time. That's a-okay. Here's 0. Here's 12. Here's negative 9. At negative 9, it's going to be a closed circle. Again, greater than or equal to, this one is closed. So we're going to use a closed circle. And we want all the y values that are bigger than negative 9. That's everything to the right. Alright, let's try the next two. I have 8x is greater than or equal to 2. So I'm going to divide both sides by 8. Divide both sides by 8. And now I get x is greater than or equal to 2 eighths. Okay, 2 eighths. They're both even. And 2 divided by 2 is 1. And 8 divided by 2 is 4. So this is going to be 1. X is going to be greater than 1/4. So let's show that on a number line here. Get negative 2. Here's 0. And here is 1/4. Okay, so my number that I'm comparing to, x is being compared to 1/4. So 1/4 gets my closed circle because it's greater than or equal to. So I get my closed circle for 1/4. Now the question is, do I shade to the right or do I shade to the left? And so since I'm getting a little confused sometimes, I like to plug in a 0 for x, and this is going to answer that question for me. If x were 0, if x were 0, is 0 bigger than 1/4? No. So I shade away. Go away, shade away, run away from 0. Alright. There we go. Okay, some bigger numbers here. Let's see what we get. Divide both sides by 13. Divide both sides by 13. And x is less than... Hey, that's 4. Well, let's do that on a number line here. Get my arrows in. I got my 0. Negative 3, because it's fun. And 4. Okay? So, my comparison number is 4, so I want to put my circle at 4. Is it open or is it closed? And this tells me, since it's strictly less than, then it's going to be open. Now, do I shade to the left or to the right? Do I shade over here or do I shade over here? I'm going to take 0. Again, I'm going to take 0. I'm going to plug 0 in for x. And ask myself, is 0 less than 4? Well, sure it is. Yeah, 0 is less than 4, so I can shade to the left. Yeah. Alright, so that's going to be the majority of the new information that you get. Make sure it's just the same as it is in equality, the exact same, except when you divide by a negative or you multiply by a negative. But in general, we don't do that too much. So multiplying or dividing both sides of an inequality by a negative flips the sign. That's the big idea here. The homework for this section, we are going to do on page 81. So let's get our homework up here. Homework. Page 181. We're going to do problems. These are all fairly simple, so let's do problems. Let's go 7 through 29 odd. And 50 to 56 even. 50, 56 even. Yeah. Have a good day. We'll see you in class.